For decades at this point, it's been widely assumed that having multiple engines increases the safety margin of an aircraft. It's so much so that at one time insurance companies would offer a lower rate for multi-engine aircraft, despite the fact that they have higher procurement costs. However, since Flying Magazine released an article challenging that notion years ago, there was a rise in insurance rates that followed for multi-engine aircraft, though I'm not familiar with current rates. Still, it shows that there's some contention on where the truth lies, so I wanted to investigate the topic for myself and see what I could determine. Multi-engine theory. The theory is pretty straightforward. In a single-engine aircraft, you have one singular power plant. If it goes, you're automatically converted to a crappy glider. In such a scenario, you have one option, and that's to find a place to land. With two engines, you have redundancy, losing only 50% of your power output, and thus allowing continued operation of the aircraft in the event that a power plant fails. Now, in fairness, there are plenty of examples of this happening. In fact, just recently, a Southwest Airlines 737-800 reported an engine failure on takeoff from Indianapolis, and managed to land safely.
Yep, Tower Southwest 2399, we need to declare an emergency.
Tower 2399 or Roger, say altitude, maintain 3000. Tower 2399, do you need equipment standby?
Yes, Southwest 2399. Yeah, we'll set it for 23 right for now, Southwest 2399.
2399, Roger.
Coach, Southwest 2399.
Tower 2399, go ahead.
Alright, we're ready to take vectors for the approach. Just if you would, let the folks on the ground know. We will stop on the runway initially till we're cleared by the fire department, and then we'll be able to taxi you back to a gate from there.
So 2399, thank you. We'll pass that along. You're cleared back to Indianapolis. Your radar vectors, flighting 140 now, maintain 3000.
Heading 140, maintain 3000, Southwest 2399.
Another example is of an A-10 piloted by Gary Wolf that was hit by a surface-to-air missile during the opening stages of Iraqi freedom. Despite losing an engine, the pilot was able to land the Hawk safely in friendly territory. So clearly, there's some merit to this notion. It's not like it's coming out of nowhere. The problem is, however, that there are more design considerations that have to be taken into account, other than the number of engines. The notion two engines are safer than one is not necessarily true due to these additional factors, and thus serves as an oversimplification that leads to ignorance and a false sense of security. It's not so simple. It's true that having two engines does increase redundancy, but redundancy itself can lead to problems. In the case of military aviation, the deciding factor was never redundancy, but simply a power requirement that one engine can't fulfill.
The reason that the F-15 and that class airplanes were twin engines, from my perspective, is not from safety. The reason that they were twin engines was because an airplane weighed 40,000 pounds, and when we wanted a 1.2 to 1.4 thrust-to-weight ratio, nobody was making any 50,000-pound thrust engines.
There was a time where jet engines were maturing rapidly, and they did have major issues like titanium becoming too brittle from absorbing hydrogen. There was also immense trouble attempting to manage the increase in pressures needed to extract more thrust from the engine, leading to advances such as variable geometry blades. This allowed the operating envelope to increase when in the air fulfilling a mission, but also allowed for it to operate on the ground at low power settings without stalling. However, since these issues are ironed out, allowing for higher pressure ratios, and with maintenance practices becoming so strict, it's more common for an engine to fail catastrophically when it does fail. This means it's likely to take out multiple other components like hydraulics, fuels, or even the other engine. A good example is the F-14 that exploded while flying supersonic over an aircraft carrier. Thankfully, both crew escaped. For aircraft like the F-15, F-22, or the F-18, an engine failure would just about guarantee destruction of the other engine, due to their close proximity. Here we have an F-15 with an engine fire. The airspeed kept the engine fire from spreading forward to the afterburner area, but the loss of power forced the pilot to come in fast to maintain controllability, meaning in the end he overshot the runway and had to eject anyways.
Say again. They're stopped. It's not going to stop before the end. I'm going to have to punch. We're here. get out.
A best case scenario would be an F-14 with the engine spread far apart. We do have an example of an F-14 piloted by Kara Hallscreen experiencing a compressor stall. The engine failed, while the other remained operational. Unfortunately, due to how off-axis the engines are, the rider didn't have enough authority to counter the yaw induced by the required engine output to try and keep the plane airborne. Unlike our earlier example with the F-14, this pilot was not so lucky.
Wave off power. Raise your gear. Raise your gear. Power. Eject, eject! Who's plane guard?
But you'll notice there's a difference between our airplanes and the Russians in that our engines tend to be quite close together. In fact, ours are quite a bit closer together than the F-14, for example. We've liked that because it essentially gives you centerline thrust. And an engine out situation, loss of one engine, doesn't give you an asymmetric thrust problem similar to the one that the MiG-29 had in Paris.
This brings up another complication. While it is true that you lose 50% of your power output in the event of an engine failure, you will lose more than 50% of your performance. The more off-center line the engines are mounted, the more moment that they have, causing additional yaw. Even two engines mounted right next to each other will be able to produce significant yaw, but this increases the further out they're mounted. While planes like the Cessna Skymaster do exist, the vast majority of civilian aircraft will have the engines mounted with significant distance from the center line. The dead engine will essentially act as dead weight, while not compensating for its drag, causing Dutch roll in that direction much like a rudder input would. To counter this, the pilot will need to use a combination of rudder and aileron, with the exact combination depending on the regime of flight to counter this tendency. This too will increase drag as you're exposing surfaces to the oncoming slipstream of air. How detrimental these factors are will depend on the aircraft you're flying. For example, if you're flying a P-44 Seminole, you're likely not even getting off the ground in many locations, such as Reno. In the case of the Baron, you can at least achieve somewhat of a climb, though it's not going to be great. The Paranoia Phantom. During my research phase, I went through several hundred cases of engine-related mishaps for the P-44, the Beechcraft Baron, and the DA-62. I will say I saw a lot of situations where people were missing qualifications for their flight being the main cause, such as flying an IMC or having no multi-engine rating. Besides that, the vast majority of cases of engine-related mishaps that I came across involved training for single-engine operations near an airport. I cannot stress this enough. The amount of engine-related mishaps that resulted in single-engine training while in the vicinity of an airport far outpaced the number of actual engine-related mishaps resulting from an engine malfunction. Additionally, I did come across a trend that I was not expecting. I chose the P-44, the DA-62, and the Baron because I wanted a performance gradient made of low performance, medium performance, and high performance dual piston aircraft. What I found is both the P-44 and the Baron rarely were able to recover from an engine failure. In fact, the number of recoveries between both in my sample size were less than what you can count on one hand. Meanwhile, the DA-62 did have a few more examples of engine failures to pull from than the other two. But even then, it was able to recover just about every time and land safely. Now, there's a ton of factors that I would like to look into, but I think the major one is the fact that the DA-62 is a European aircraft. Sure, they are operated here in the US, but the majority are going to be operated in Europe, and so within a different authoritative agency, mainly ICAO and the local country's rules. So there are likely some differences to pilot training, but I'm not familiar with ICAO or FAA training standards in this regard to say anything definitely. Finally, we'll round this off with commercial aircraft. ETOPS, or Extended Twin Engine Operations Performance Standards, is a design requirement placed on commercial aircraft conducting cross-oceanic flights. Essentially, the standard dictates performance and design criteria that must be met in order to be within range of an airport for diversion purposes at all times during flight. The more robust the criteria that are met, the longer these distances can be, opening up more direct routes. For this reason, you can find plenty of examples of commercial airliners losing an engine and recovering safely. It is, after all, a fundamental part of their design. Conclusions. Overall, I just want people to recognize that while having multiple engines can be safer, in some scenarios it may actually increase the chances of failure. It's not as simple as a blanket statement. Like many things, it depends on various factors. Different aircraft would be created under different design criteria for different purposes and different regimes of flight. And the result is some will be capable of performing single-engine operations in the event of an emergency, while others are likely to fail completely. So when wondering if having a second engine does make the airplane safer, remember that it increases the chance of having a mishap in the first place. But if the plane's purpose is permissive enough for designers to take that into account with their design, then overall it is probably safer.